Hi guys, today we're going to talk about reducing fractions, and your book wants you to do it by prime factorization, so we're going to do that method first. But why reduce at all? Another word for reduce is simplify. Imagine you are doing a research project and find out that out of 243 students surveyed, 162 of them have satisfied their math requirement. So you write 162 over 243 in your report, da 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 da. But what does that mean? Is that a lot of students? Is it less than half? Is it gobbledygook? Simplify. Okay? Your reading audience does not like to see big, ugly numbers that don't make any sense. They want the numbers to make some kind of sense, or you get ignored. So, the prime factorization of 162, I happen to know, is 2 times 3 times 3 times 3 times 3. And the prime factorization of 243, I happen to know, is 3 times 3 times 3 times 3 times 3. Do I expect you to know this? No, that would be ridiculous. I'm going to show you another method too. Anyway, 3 over 3 is 1, so we get to get rid of that. 3 over 3 is 1, 3 over 3 is 1. Da, 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 da. So it turns out this all just really equals 2/3. That's what should go in your report, because 2/3 makes sense to people. It's just a little bit more than half. I understand 2/3. So why would I say 126 over 252 when I simply mean 1/2? We'll get to that later. So using prime factorization, let's simplify 45 over 60. We've done these before. 45 equals 3 times 3 times 5. 60 equals 2 times 2 times 3 times 5. And 5 over 5 is 1, that goes. 3 over 3 is 1, that goes. And what I have left over is 3 over 2 times 2. Piece of cake. How about 32 over 48? This is one that I happen to know and love, but like I would not expect you to have this memorized. 2 times 2 times 2 times 2 times 2. And 48 is 3 times 2 times 2 times 2 times 2. Okay? So 2 over 2 equals 1. That goes, that goes, that goes, that goes. So in the end, this all just equals 2/3. Okay? This method is very helpful if you are very good at timesing and dividing. Otherwise, we need another method. So when I call this reducing by dividing by 1, I'm relying on the fact that 5 over 5 equals 1. Okay? That's why this works. We're going to divide by 5 over 5, but we're really just dividing by 1, so we're not changing the answer. 15 over 20. Both 15 and 20 are divisible by 5. So let's start there. I don't need to know the whole prime factorization. I just need to know one number that works. And let's divide it out of there. 15 divided by 5 is 3. 20 divided by 5 is 4. Those are not divisible by anything else, so we're done. How about 18 over 42? There are a lot of choices here, and my point is you don't need to know them all. You just need to pick one, and each time you pick one, the number gets smaller and it gets easier. You could use 2 or 3 or 6. I'm going to use 2 because I think it's easier. So 18 divided by 2 is 9. 42 divided by 2 is 21. It's more obvious to me now that these are both divisible by 3. So let's do that next. 9 divided by 3 is 3. 21 divided by 3 is 7. And we're done. 40 by 48 is another good example of just starting with 2 because they're both even. But you have a lot of choices here. We can divide by 2 again. And we can divide by 2 again. Now I realize too late that I could have just divided them both by 8. But this is why I say it doesn't matter which number you choose. It doesn't matter if you get there quickly or slowly and carefully. Just do it well and you'll get the same answer. How about 21 over 35? Those are both divisible by 7. Okay. Oh, there's that 126 over 252 from the other slide that I just know is a half, but don't know why. Well, what can we divide by? They're both even, so let's divide by 2. So we have 63 over 126. Well, now it's obvious to me that they're both divisible by 3, so let's try that next. That's 21 over 42. Now it's obvious to me that they're both divisible by 7, so let's do that next. Oh, and of course, these are both divisible by 3. We're at a half. Okay. Now, it wouldn't be very kind if I didn't just tell you that if you put 126 in the fraction button, 252, and hit enter, your calculator is going to do this for you. Okay? It works with all of them. 15, fraction key, 20 is going to give you 3/4. Ooh, should I have just told you this in the beginning? No, because you need to know how to do it. Check it with your calculator, but know how to do it. Okay? Hope that helps. Let me know if you have any questions. Thank you.